Alright, I'm going to work number 7 from 6.4 just because I need to follow up with that first video. So that first video you should watch and understand what's happening with inverse trig functions. And the most important thing to remember there is in order to have an inverse, the function has to be 1 to 1. So we had to restrict our domains. And so the sine function was restricted to negative pi over 2 to pi over 2. The cosine function was restricted to 0 to pi. And then our tangent function was restricted to negative pi over 2 to pi over 2. All right, so when you list these angles, when you're finding the inverse of a function, you are finding an angle. So you're going to have to list them within these particular domains. All right, now, if we just practically think about what this is, then remember you can only have one positive value and one negative value. Well, if I have a positive value coming from sine, that's going to be from quadrant 1. In fact, any positive value is going to be coming from quadrant 1. All right, and then if I have a negative value, that would be negative pi over 2. You would go clockwise, and that would be from quadrant 4. So we can only have one negative value, and you know sine is negative in quadrant 4. So we're going from negative pi over 2 to pi over 2 with sine. Same thing with tangent. And then cosine's a little bit different because if we use quadrant 4 with cosine, that would be positive. Remember, cosine's positive in quadrant 4, so we can't use quadrant 4. So that's why we're using 0 to pi or quadrant 2. All right, so my positive values, well, my angle will come from quadrant 1. My negative values, my angle will come from those quadrants. Now, before I actually work A, B, and C, I want to, because they're all negative, and when the negatives may be a little bit more difficult, so I need you to understand what's going on. Let's do all three of these, except let's look at the positive values. Because if we're looking at the positive inverse, all those angles are going to be coming from quadrant 1. All right, so we're going to do the inverse sine of the square root of 2 over 2. So this is what you need to think about, however you learned your exact values. So I taught it with triangles. You might have learned it with the unit circle, but you had a chart. So you had this chart that looked like, and I'm not going to take the time to do all this, but so we had like 30, 45, 60, right? So let's think about the sine of 30 degrees was 1/2. The sine of 45 degrees was the square root of 2 over 2. The sine of 60 degrees was the square root of 3 over 2. All right, so what we're doing with inverse, instead of me asking you the sine of some angle and you looking at the exact value, I'm asking you for the angle. So I'm giving you the exact value and you're giving me the angle. All right, that's what automatically when you hear inverse, you should think, okay, I'm looking for an angle. So if this is asking for the sine of what angle is the square root of 2 over 2, well, the sine of 45 degrees is the square root of 2 over 2. So this is going to be 45 degrees or pi over 4. And it depends. If it asks for radians, make sure you convert your degrees to radians. All right, the B part, I'm going to make that positive too. Same thing, the cosine. The cosine of what angle is the square root of 2 over 2? Well, the cosine of 45 degrees is the square root of 2 over 2. All right, and then the C part, the tangent. The inverse of tangent is 1. All right, so the tangent of what angle is 1? Well, there we go again. We've got 45 degrees. So it's pi over 4. Notice that all three of these came from quadrant 1 because all of these were positive. All right, now we're going to make it a little bit more complicated. So let's go back and do, let me erase this and get it out of the way. All right, let's do our negative values. So now I'm looking for the sine of what angle is the square root of 2 over 2, except this time it's negative. Now, the good thing about this is they kind of made it easy for you the way they restricted the domain. So if I'm looking at this, what you need to think about, and really you would do this with any problem, if they give you a negative value, always find the positive value, because that's going to be your reference angle, and then use it to find the angle in whatever quadrant you're looking for. All right, now this particular case, I've got negative square root 2 over 2. Well, remember that my negative sine value has to come from quadrant 4. But remember that we're just going clockwise. So even though my reference angle is pi over 4, if I went clockwise, that would just be negative pi over 4. So that's my answer. So it's negative pi over 4. All right, the same thing with tangent. So I'm looking for the tangent, the inverse tangent of negative 1. Well, the inverse tangent of 1 is pi over 4. And remember my inverse restrictions. So I'm going to go the opposite direction because I need it to be negative, and so that's going to be negative pi over 4. All right, and then the last one is cosine. So this I would consider a cosine the trickiest, because I know that, and I'm going to find the negative. So I'm looking for the negative square root 2 over 2. All right, so I know that the cosine of pi over 4, the cosine of pi over 4 is the square root of 2 over 2. But now I need the angle that gives me a negative value. Well, that angle is coming out of quadrant 2. So now you have to think about how you get your angles and how you use your reference angles to get an angle out of quadrant 2. Remember, our reference angles always go from the x-axis. All right, so if you think about this, if you're trying to find the angle out of quadrant 2 and 45 degrees is your reference angle, so I know 45 degrees is my reference angle. So I'm going to do 180 minus 45. And so I know this angle is 135 degrees. Or if you need to write that in radians, then it's 3 pi over 4. Okay? So this is quadrant 4, this is quadrant 2, this is quadrant 4, and you have to keep them in your domain.